Hi, Dan Kelly here. What I'm going to do here is I'm going to show you how to read and plot digital elevation model, DEM, data in Julia. And you can do this in R and in Python, MATLAB. It's really easy to do. And the gist of it is here. First, I'll show you maybe the results. I'm going to be showing you how to make these two diagrams. This is a diagram of the get them on the same scale. Okay, this is a diagram of the sort of southern part of Halifax. This is Point Pleasant Park in here where I'm circling around. These sort of things here are docks. The black is indicating the sea, the ocean. This is the northwest arm over here. This is showing elevation in meters, this red color, 40 meters, and the blue color is then down to 0 meters. And you may be wondering what this sort of funny little cut is between the two islands. That's actually human-made. That's a railway cut. So railway comes into Halifax on the western side, and they sort of cut through rock. Heck of a process. Cut through rock, and so there's railway lines going in here. So then ships come up here, and products coming from like Western Canada, grain from Western Canada, etc. And it's two-way traffic, obviously. And this is just one of the two ports in Halifax. That's the first picture. And the second picture is the y derivative, the north-south derivative of that last picture. Okay, I'm going to show you how to do it. So this is Julia code. In line 2, the line number is on the left. Line 2, I'm asking for some libraries. The function that reads the data are in lines 4 to 8. It's a function called read_dem, and it takes one argument, which is a string, name of a file. What I do in line 5 is I'm reading it, I'm loading it with this diffimages.load, and I'm converting it into a float 64. I don't know. I think it's a float 32, or I'm not sure what it is, but I just, it's kind of my practice to make stuff into a float 64 without even thinking. What I'm doing here is I'm replacing any numbers which are -9, of those nines, with 0. This is some kind of a missing value code. Now I could actually look in more detail in, and by the way, there's multiple packages that will read these sorts of files. And it's possible that some files have different missing value codes. And so this is maybe, if I ever run across that files, I'll rewrite it and be a little more clever about that. The other thing is I happen to know, I don't really need this for what I'm saying, but I happen to know the delta X and delta Y in the image. And so I'll use words like meters and kilometers when I'm talking about this. Okay, so what I do in line 10 is I read the file, and then I make two graphs. One is a graph of elevation, one is a graph of de-elevation dy, derivative with respect to y. It's a first difference calculation. See, diff, line 22 is doing a first difference. I don't really have to do this, but in line 23, I'm making it in the same size and putting a bunch of zeros on one side to make it have the same dimensionality. Don't actually need that here, but I was thinking this is the second view I'm going to show you is a bit like there's a light coming from the north. And if I wanted to make a light coming from the northeast, no, sorry, the northwest, which I think is quite common in maps, then I would compute the other derivative, and I would want them to have the same scale that I could combine the two, but I'm not doing that here. Okay, and I'm setting a location with I naught and J naught, and I'm setting an extent with 2500. And in here, this first, like line 16, this is really the guts of it here. I'm making a heat map of that. And the rest is just controlling things. I'm setting the color scale to turbo. That's a kind of a spectrally sort of color scale. And I'm doing some other stuff. And the only real difference in the second is I'm setting a color scale called balance. It's kind of going red and then like blue and then white and then red. And also I'm setting a limit that says 0.5 meter per meter, if I'm correct in saying the horizontal resolution is 1 meter. Okay, so let's have a look. So going between the two, first off, this one, you can see there's some geological features here. This saying it's human-made. This is not human-made. These funny striations have something to do with the interesting geology in the region. I'm not an expert on that, but okay, so now I'm going to zoom in here. And you can see this interesting geology, but this is human-made. These are some roads or paths or lanes. I don't really know what to call them. They're not really roads, but paths, I guess, maybe. I'm not sure. So you can see some features, but it's a little hard to see. When I differentiate it, maybe I'll just go like this to get sort of full scale. When I differentiate it, you see all kinds of detail. So let's just have a look here. So one of my common runs is to go, I live sort of up here someplace, and one of my common runs is to go along this road where a bunch of rich people live. South Park is what that's called, and jump. I just jump over. No, I take a bridge. DEM sees through bridges, like it sees what's below the bridge and fills it in. So there's a bridge going across there. Excuse me. And continue taking off this in this direction. And when you get to this point, if you can see this line here, I don't remember the name of that street. I don't look at the street names when I run by, of course. Uh, down below that, to the south of it, is Point Pleasant Park. And so basically, an awful lot of people enter the park either here or here. Those are the common ways. You can also enter it down here. If you want to start a run like very flat along the harbor, you can do that. Some people do that. I go by this way usually. And yeah, so you enter, and now we're in a lane here. This is like a dirt path, and there's you go along, how to say this, you go along to the left, and then at a certain point, you can take a sharp right and go up here, and you can see if you're interested in it, um, some rock formations, which my friend Paul Hill, another prof in my department at Dalhousie, says are sort of a signal of prior turbidity currents. Really interesting to see. If you're interested in history, there's you can see there's a fort here. Fort Ogilvy, I think is its name. And I've seen this a gazillion times, but I never quite realized that there's this sort of, but it's not a moat, but not sure what you would call it, but some sort of protection around it. Um, Now, if you're a runner, you can make an image like this, and you can find your favorite routes and maybe even find some new routes as well. So here's a route going through here. Um, Oh, um, just going back up here. This is Black Rock Beach, just to sort of orient you. This is Black Rock Beach here. And if you are running here, and I don't see any evidence of it here, but um, maybe I'll say one day out of 10 or one day every 2 weeks, you'll be able to see beach cusps there, which is interesting sand formations caused by wave patterns. And you can take my course in physical oceanography at Jahazi to learn more about that. Um, okay, I guess that's about what I was going to say. The real guts of it is just a few lines. Maybe I'll just say it's really easy to work with digital elevation model data. You don't have to buy software or anything like that. And you also don't have to, if you know how to code at all, you don't have to just rely on a web page giving you views. You can construct a view by yourself. Um, and a simple web search will find pretty quickly, you'll find whether your 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 region has any digital elevation models. And I think over time, just more and more get done in more and more, towns and cities and so forth. Um, right, that's it. Hope you enjoyed this. Take care. Bye.